Hi, welcome back to my channel. Today I'm going to talk about Kubernetes. So, what is Kubernetes? Deployment architecture of Kubernetes, Kubernetes components. Ideally, developers do not know all these details, but better to understand first what is all about the product and how it evolved, why this product is so popular, so that we can get more uh, low level details and we can get good hold on that particular product. So Kubernetes is a portable, extensible, open source platform. Portable means I can host it in laptop, I can host it in desktop, I can host it on premise, I can host it on cloud. That is called portable. And extensible, why do we use that extensible term? That means the current Kubernetes product, you can take it as a source code and you can customize as you need it according to application needs. And we can customize and we can build or rebuild this product and host it. Because it is an open source, no license cost will be paying by you to the open source team. Okay, so that is the reason they clearly specify it's a portable platform, extensible platform, and open source platform. These all three put together this product so popular to manage and maintain a containerized workloads and services. Containerized means you might have heard about the names Docker, uh, containerized D, another set of services that is also available, and so forth. So, wherein you will build an application with a Docker container and you create that image and upload that image, and then you get that image and then you launch a Kubernetes pod. So, that is what it is. And Kubernetes, you know, widely used today to host any type of application. It could be Java based, C Sharp.NET based, or Python based, Perl based. You can name it whatever you want. Those are possible to host it. The thing is, you should have the product is up and running in your environment. That is the mandatory thing. This Kubernetes terminology arrived from a Greek word. So if you look at the meaning of the Kubernetes word, helms, helmsman or pilot. That means who drives this is called a Kubernetes. So they use K8S. K to S in between 8 letters are there. That's why they call it as K8. This product is developed, productionized in Google's platform last 15 to 20 years, and then they have open sourced in 2014 to the Linux Foundation team. Linux Foundation team started adding a lot of sort of features as it is an open source given by Google, right? And then now that product is being used to orchestrate application developments, which is of lightweight. Okay, so that is the history. As I said, Kubernetes is used to host any type of long application, but which language used to develop this product? Kubernetes is used to develop this product. Go is the language. Okay. So if you are interested to know about Go language, you can go ahead and Google it. If you look at the application hosting eras from traditional to virtual machine to containerized runtime, how it is being developed. In the olden days, the applications are hosted, okay, on the hardware, and then there will be software running in it, and you host the application. Say this is a Java application, say this is a C Sharp application, this is a say this is a C++ application. So you cannot able to control the resource consumption of all these applications because Some applications may be consuming high CPU and RAM and processors. Some applications do not. So basically, you cannot control the resources. That is the bottleneck with respect to the traditional era application development. Then what they slightly changed the era from that to virtualization. What you have the hardware, you have the software. You need to have a virtual kind of a machines to be built. To build a virtual kind of a machine, you need a a bridge. What is that bridge? You can call it as a hypervisor or virtual box. Different types of vendors, they are providing different ways. So by enhancing this bridge, you can have your physical machine where you can run a virtual machine. In that virtual machine, you can host the operating system, and then you can write your applications and host it, your applications on it. That is what it is. So this is all together a box. This box is decomposed into multiple virtual machines, which is going to consume this physical machine hardware and software. And this virtual machine has its own operating system and own application related deployments. So that is how it was gone. Now that has moved to the containerized runtime deployment. That means you have the operating system, you have the virtual machine. On top of the virtual machine, you have the containerized runtime is running. That is a Docker and so forth kind of a technologies. And in that virtual machine, you can launch as many as applications. So that is a container which is running. So that is how this orchestration has been moved from traditional to virtual to containerized. You can have a containerizer which is a small operating system containing, suppose something. Here you see that virtual machine as operating system. Here you have a container. That container itself has a operating system, and where you can host the application. So that is how it has grown up. What are the advantages when I am going with the Kubernetes platform? If you look at it here, agile application creation and deployment, increased ease and efficiency of container image creation compared to virtual image use. That means you can build a virtual machine, or you can build a container, which is easiest process. Virtual machine means you have to create a virtual machine, you have to create the RAM, operating system, install all these things. It is a complex process which will be taken care by the administration. But here, as an application developer, I don't need to know all those things. So what you can do is you can build your source code and you can integrate with the certain tools that will do for us job. That is called the image creation. Your application bind with the existing image. It is the easiest process rather than you create the image. And continuous deployment, development, all those things, integrations. So whenever you want to bring up the containers, you can bring up. Whenever you don't need the containers, you can kill the containers. That is also supporting. And the dev and ops separation of concerns. Create application container images at build time rather than the deployment time. What saying, before you plan for the deployment, you are able to create the images ready before you do the deploying. That means it is a decoupling applications from the infrastructure. You never depend on the infrastructure. And the observability. Not only the surfaces OS level information and metrics, but also application health and other signals. Say you have a cluster which is running applications, you can look at the metrics, how much memory has been used, how much disk space has been consumed. All those metrics you can definitely calculate during the runtime. So that is what it is. And environmental consistency across development stage and production. So whenever you host a particular Kubernetes or platform service, you will host it in the different environments, the same version configuration, so that it is easy to manage and maintain. You don't have to struggle with the operating system, this version, that version, this conflict, that conflict. Such kind of things can be avoided. And cloud and OS distribution portability. As I said, it can run on Ubuntu. I mean, you say you can have on-premise. On-premise, maybe you are running Windows. Yes, you can go ahead and you host it on Windows operating system as well. Here they are saying that you can host it on any type of operating system: Ubuntu, Red Hat, Core OS, on-premise, major public cloud, anywhere else. Application-centric management raises the level of abstraction from running an OS on virtual hardware to running application using a logical resources. That means you have a box. The box can be decomposed into virtual machines. Virtual machines will have the runtime environments. Then you can go ahead and logically consider your resources and host it. And loosely coupled, distributed, elastic, liberated microservices. Today, the trend has changed. All the applications are from monolithic to lightweight containerized applications building in which is using microservice fundamentals. So that means you don't need to struggle having a bigger hardware sets and all. If you have a minimal hardware sets as well, enough to host your microservice. And resource allocation also very easy, and resource utilization also you can be efficiently monitor and track it, and then based on the need you can do auto elastic set. Those are the benefits which are giving using the Kubernetes. So now you see the Kubernetes components. So Kubernetes has several different components: cloud provider API and CCM. CM, if you look at here, cloud controller manager. CCM stands for. CM means controller manager. etcd, it is a persistent store. I'll give you a little more background. First, try to understand. This is a Kubernetes cluster. In this Kubernetes cluster, you see a variety of the components. You will find it. This dotted one, call it as the control plane, which is basically controlling all of your Kubernetes hosting service related things, which is using certain default services, that is etcd, scheduler, API, CCM, CM. These are the set of services which is owning by the control plane, and to control the nodes where it runs kubelet proxy. These are all the proxies which is communicating with the API server, which will be orchestrating all of our applications on these nodes. Okay, so this is what it is the representing. This white color box, it is saying as a node. This is node 1, node 2, node 3. This is all about a Kubernetes cluster, and this is one node which is running a Kubernetes control plane service. Okay, so now let us understand what types of components Kubernetes is underlying it is using. Kubernetes components are categorized into different varieties. Okay, if you look at it, control plane components, kube API service, etcd service, Kubernetes scheduler, Kubernetes controller manager, cloud controller manager. If it is running in the cloud, this is being used. Okay, so these are the major components which is running in the control plane service, which you have seen in the previous diagram. Okay, and you have the nodes, right? In the nodes as well, you have the certain services: Kubernetes service, kubeproxy, and container runtime. So container runtime, nothing but Docker. There should be some container service to be running on the node so that you can able to host your application. And kubelet proxy, which is used to communicate with the API service, all these networking related things which will take care. And kubelet is basically used to communicate and notify about the pod status, all those things. And other set of components also widely used. Say your application may be having a DNS. So for a DNS representation on service is being used. That means IP to hostname, hostname to IP you want to convert, and add-ons. Say you wanted to add on any type of a services like a deployment based service or say stateful based service, you can add on. and it will give you a dashboard service, that is the Kubernetes API service, where you can see all the resources which is there, and container resource monitoring. So you will host a lot of services, right? Uh, you need a resource monitoring, uh, user interface, right? So that you can control that whether that particular application is using 100% of the CPU or 80%, whatever the percentage. So that is, and what is happening inside the Kubernetes orchestration services. You need to know if there is any failure, what is the reason it failed. So they log the information which is related to the services which is running, and network plugins, because you host your application according to your network segments. So you need a network-based plugins also to handle network-related switching, routing the information between the services. So here a brief note I have given Kubernetes component definitions. What I'm saying is etcd, a highly available key value store for shared configuration and service discovery. That means this particular service having key value information which can be shared across all the Kubernetes platform, which you have seen, control plane, nodes, blah, 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 right? And Flannel. Flannel is an ETC backend network fabric for containers. So if you want to run any container, you need a network so that you can expose that service outside of your container, right? So you need one of the networking component. That is what it is being used by Flannel service. And Kube API server provides API for Kubernetes orchestration. The entire flow orchestration will be managed. Kube controller manager enforces Kubernetes services, what service can be used, and Kube scheduler schedules a containers on the host. You have seen there in the diagram 3 nodes where you can host the containers which you need to host it on specific node or on all the nodes. You can definitely define in a Kubernetes scheduler. And Kubelet is a process container manifest, so that containers are launched according to how they are described. Manifest is a concept in Kubernetes. It is represented using YML file, so we call it as a manifest configuration file. There you instruct how my container should begin, what kind of type of the container it is. All those things will be described as a developer. That is the thing where we have to write it. That will take care and respond back to the Kube API server. And kube proxy provides network proxy services. So whenever the communications happening between your API server to Kubernetes nodes and Kubernetes nodes exposing, all these things will be monitoring. And container service, container runtime, you can use container runtime as a Docker. This is how simple underlying architecture of hosting Kubernetes platform before we launch or we host any application into the Kubernetes architecture. Okay, if you look at it here, this is a master service which is running kube scheduler, kube API server, etcd, kube controller manager. These 4 services makes enable of our API server, which will track all the nodes. See here, you see there are 4 set of IP addresses, 130 ending with 131, 132, 133, right? So that means in this particular case, this is the one which is a master, which is controlling all these 3 nodes and also tracking each applications which is hosting in these nodes as a container application. So you see here 131 is one compute node which is using Kubernetes, kubeproxy and Docker Flannel, because the backend service is needed to store all these information of key value pairs about these services, right? So this is how it is communicating with its master. So this is the architecture of the Kubernetes deployment as a service. Here we host in this whole node, we host our container. Here also we host, depends on how do we wanted to host it. That details we need to configure in Kubernetes scheduler with the manifest file as we have specified. So scheduler will know that as soon as you prepare that manifest file, host it, and apply certain commands, so that is going to be hosted here, here, and here, 3 nodes. So these are the reference links if you would like to know. I have created one Docker image already for Kubernetes. I will give a hands-on session in another video. This is this is the video which I have described to understand about Kubernetes, what are the components exist and how Kubernetes does the orchestration, low level details and the deployment architecture model of Kubernetes. So once you are familiar with this, then you can definitely build an application and host it. Probably you may not build this cluster, somebody else will build it for us, or if you go with the cloud native, we can launch it in 5 to 10 minutes, because they are providing this entire orchestration in a simple manner uh, from the Azure, AWS, OpenShift. Okay, so thanks for watching, and share it, like it, subscribe it. This is a part 1 series. I am coming up with a part 2 series where we can understand the Kubernetes different manifests and hands-on session, wherein I am running one of the local Kubernetes engine, so that I can give you a live example. Until then, thank you.